Hello everybody, this is Mr. Hennon with a little Henstitute help. So this was one of the problems on the gravity orbits Google form, and we didn't spend a lot of time with it because I don't want to spend a lot of time with it, but I think it's still kind of an interesting concept. So the basic concept is if you wanted to create artificial gravity in space, what you would need is you would need some kind of spinning platform. So basically, the person would be standing here, and this thing would be spinning around in a circle. And as it does that, there would be a centripetal force on the person, and that centripetal force would basically equal their weight. So centripetal force would equal the weight of the person, and in this particular case, we do mv squared over r. That would equal m times g. The mass of the person would actually be irrelevant, and so we can get that v equals the square root of g. So this is like our vertical circle. This is like the minimum speed to go to the top and stay inside the circle type of thing. Here, it's actually how fast so that it stays going. And what that does is that's assuming we want to get gravity to be 9.8. So I could actually do this as just m times a, and I could use any kind of acceleration if I really wanted to. In this particular problem then, so I should be able to plug in the square root of 9.8 times, and then they give us the radius. We want it to be 460. Okay. So I put those in, and then I should be able to calculate how fast this thing needs to spin. And if you do your hand-to calculator, you're basically taking the square root of about 4,500, 4,600, which gives you about 67 meters per second. So this basically has to spin at 67 meters per second. 67 meters per second, 67 meters per second around a circle. Basically, the person does as well. And so that's kind of the beginning part. However, when you look at your answers for this one, you're like, wait a second, they don't actually want a speed. They want to know with what period must the station rotate. In other words, how much time is it going to take to rotate? So that one's a little bit different. What we're going to now do is take this idea, and this is why this is kind of an interesting problem, but we're not going to spend a huge amount of time on it. So we're going to go back to this circular motion idea, and we're trying to find big T. So big T would equal 2 pi r over your speed. So we would take 2 times pi times this 460 and divide by this 67, and we should be able to get the time. So one of these will fit. I'm not going to tell you which one, but one of them will fit once you do that last little step. So the first part was realizing the Gur equation would work, and then you have to go back to circular motion, which we just got done with, and use one of those equations to find your period. Hope that helps.